Okay, now an example. Tapestries hung in an air-conditioned room have a normal water content, W, of 8 kilograms. When moved for repair, they dried out. When returned to air-conditioned rooms, the rate of increase of their water content was proportional to the amount of water lost. Okay, let's just think about what's happening there. We've got tapestries that have got quite a lot of water in them. We're taking them away and they're getting drier. We're bringing them back and they're getting more moisture into them again. And the rate of increase is proportional to how much they lost. So if we know that the normal amount of water that they had was 8, but the amount of water content that they have now, any one of them, is W, then the amount of water they've lost would be 8 minus W, wouldn't it? And so we're shown here that dW dt, in other words, the rate of change of their water content, is proportional. In other words, it's K, where K is some constant of proportionality. It's K multiplied by 8 minus W. Okay, so we're given that. Now, the first part of the question says, prove that for any constant A, W equals 8 minus A e to the minus kt is a solution of the differential equation. Now, you haven't really been asked a question in this sort of wording before, so let's consider what it means. What is a differential equation? Well, an equation is just something that's got an equal sign in it with something on both sides that's equal. But to differentiate, that gives us a differential equation, doesn't it? So this is the differential equation that's being referred to. Now the question is sort of asked backwards, I suppose, because we're used to being given some sort of formula and being asked to differentiate that. And in this case, they're giving us the differentiation and saying, prove that that's what you get when you differentiate this, effectively. All right, so what I would do here in any sort of proof question or show that question, as soon as they've said prove, look at the thing that we're trying to actually prove. We're trying to prove that this is going to work for this. All right, so I would just start with this and say that the left-hand side is equal to dW dt. And now we can figure out what dW dt is by just differentiating this version of W that we've been given. So we're going to ignore the 8 because it's got no t's in it and we're differentiating with respect to t. We're going to differentiate what's up here in the power and get minus k, bring that out the front, multiply it by our minus a, and that will give us positive ak, which can be written in either order there, the k first or the a. In fact, let's write the k first. And then we get the exponential part. We just need to rewrite that exactly as it was. Okay, now we've got that bit, we can rewrite this in a different way. I'm going to take this formula and over on the side here, I'm going to I'm going to subtract 8 from both sides. So if I do W minus 8, then I'm going to get minus A e to the minus kt, like that. Now I can see here that if negative all of this is equal to that, then A e to the minus kt must be equal to the negative version of this, which is actually just 8 minus W, isn't it? So I would do that bit of working over on the side because it's a way of taking what we were given here and rearranging it. And now I can sub, this part here is equal to that, so I can sub that back in and say I've got K multiplied by all of this, which is my 8 minus W. And that's sort of what it was looking like when we, on your previous notes, where we said it's quite common to get it written like this. Now we've got the right-hand side. So we've proved that the left-hand side equals the right-hand side. Now that's one way of setting it out, where we just start with the left-hand side, we finish with the right-hand side, and where it looked like we were getting a bit stuck in the middle, we did some working on the side so that we could sub that back in. Now some people like that sort of system because they can see a clear roadmap of where they're going, and when they get stuck, they can do some work on the side. Another way that you could set that out, which you might actually prefer, would be actually just to stop there and say, all right, that's the left-hand side, it's equal to this. And then over, you could either do it underneath or over on the side, depending on how big your page is. The right-hand side is equal to this, okay, 8 minus W. And now we could just sub in some things here. So we've got the K, we've got 8 minus, and now we've got an expression for W. So why not just sub that all in? 8 minus A e to the minus kt. This is probably a simpler way to do it, really. And now carefully expanding our brackets, we've got 8 minus 8 in there, so that's 0. So we've got K multiplied by, now don't make a sign error here, we've got negative A e to the minus kt. So we've actually got k multiplied by a e to the minus kt. And at that point you can say, well, the left-hand side was this, and the right-hand side was this, therefore the left-hand side equals the right-hand side. And that's a perfectly good way to set it out as well, and perhaps a little bit more straightforward if you prefer that style. Okay, a second part to the question now. So we've got question B. If w equals 4 initially. Now, as soon as you see that word initially, think to yourself, that's when t equals 0. In other words, at the start of this little experiment when the tapestries are brought back. And w equals 6.4 after 3 days, then we need to find these 4 things. So first we need to find the values of a and k. All right, let's do our working over here. So for B, part 1. All right, well, if t equals 0 and w equals 4, all we need to do there is sub that into our formula. So we had our formula 8 minus a e to the minus kt. Write that down first. And now just go ahead and sub in when t equals 0, w equals 4. So I have 4 is equal to 8 minus a times, now this part you could probably do in your head here, you've got e to the power of 0, don't you? So it's actually just this, because once we put e to the power of 0, you can see that that would just be 1. So we almost don't really need to write it. Do it like that just to show your thinking. So 8 minus something equals 4, a must be 4. All right, now we use our second clue. When w is 6.4, t is 3. So we can sub that in, 6.4 for the w equals 8 minus, we found our a, so we'll use that, 4, e to the minus k times 3. Let's write minus 3k there. Now, see what I did there? I subbed in t for 3. So I've got minus k times 3, which I wrote as minus 3k. All right, solving this, we want to get the exponential part by itself. At the moment, this 8 is in the way. So a couple of ways you could go. You could add 4e to the minus 3k to both sides and subtract 6.4. That would probably be the easiest so that everything is still positive. Or I could subtract 8 from both sides. I'll have a negative number here and a negative number here, and then I could just multiply both sides by negative 1 to get rid of it. Either way, you're going to get the same thing. If I subtract 8 here, I'm going to have 6.4 minus 8 on minus 1.6 is equal to minus 4 e to the minus 3k. And you can see there that I can clearly get rid of those two negatives at the same time. Now I want to get this part of the exponential by itself, so I need to get rid of the 4. So I need to divide both sides by 4. So 1.6 divided by 4, you can use your calculator, or in your head you can say it's 0.4 is equal to e to the minus 3k. Now we've got it into 3 parts. Something to the power of something equals something. So now it's time to retell that story as a log. So we have e to the power of minus 3k is equal to 0.4. Now this is just a number that we can find in our calculator. Remember that when we're finding a natural log with a base of e, we use the ln button, and ln stands for natural log. So hit natural log of 0.4 and you'll have this whole side. Now, how are we going to find k if it's at the moment multiplied by negative 3? Divide both sides by negative 3. So k is going to be the natural log of 0.4 over minus 3, which I can easily do on my calculator to see that k is equal to 0. Let's go 3 decimal places here. Now, at this point, if I'm going to use this later on, store it in your calculator. So go Shift, Store, and then hit the red A button. So now you've stored that answer in there exactly, and when I want it again, I can call it up by just hitting alpha, which is the red button, and then that A. So now the second part of this question is we need to find when the water content will reach 7.9. So we've got our formula here. We know what A is now, and we've got to the minus KT where we know what K is. This is stored in our calculator as the red A. Okay, so we want to let W equal 7.9 and figure out when that happens. In other words, find T. Okay, so same sort of story here. We want to get the exponential part by itself. So start by getting rid of the 8. We want to subtract 8 from both sides. That's going to give me negative 0.1 over here and negative 4 e to the minus kt here. I can very easily multiply or divide both sides by negative 1 there to get rid of my signs. So next I need to divide both sides by 4. So I'll have 0.0 0.025 here, you can use your calculator to do 0.1 divided by 4 is equal to this. And remember, I know what k is. Now I've got it as three things. Something to the power of something equals something. I can write that as a log. Always wait till you've got it in three sections. E to the power of minus kt is equal to 0.025. And now to get the t by itself, because I'm looking for when this happens, I can see that t is going to be the natural log of 0.025 divided by negative k. Now at this point I'll put it into my calculator, but I will press the natural log of 0.025 divided by negative, and when I need the k, I'm just going to hit alpha and then my red A button. So it actually looks like I'm dividing by negative A. That way I've got the exact value every time. And I get 12.077. Now, go back and think what's happening here. Time is, I think, in days, isn't it? So I'm pretty sure if t is days, then we're looking about 12 days. So a little way into the 12th day is when it's going to happen. It would be by the end of the 13th day that it is more than that if we're looking for a whole number of days. Now for the third part, we need to find the rate of absorption. Underline that word. We're not just finding W, the amount of water, we're finding the rate that the water content is changing after 3 days. Now we know that we're doing that because if you accidentally just start subbing in to this formula, and you say, all right, well, let t equal 3, what's W? You're going to go, hold on a minute, they've already told us that. But that's a classic mistake you can make. So when you're looking at a question, underline what it is you need. When, I need a number of days. Find a rate, okay, I need to see how something's changing. Now we've been told how it's changing. So what we actually need, instead of using this formula, is we need dW dt, that's the change in water content, and we know it's this. Okay, so after 3 days, we actually know what W is going to be. It's in the question. So we need 6.4 here. And we've also found what K is. It's stored in our calculator. So we need 8 minus 6.4. So at that point, I will just use my stored value of K, which is A in my calculator, and then multiply that by 1.6. And I'll get 0.488. So the rate 0.489, let's go to 3 decimal places. Okay, now I need to sketch a graph of this water content over time. Now I think the easiest way to sketch this is to consider some of the things we know. We already knew that when t equals 0, we had W was equal to 4. And we know it's approaching 8, so it lost water content, but it's going back up again to 8. Now, if you look at the basic shape of this and then consider the transformations, I think that's probably the easiest way to do it. So considering a basic graph that would look like W equals 4e to the kt, something like that, I know it's this sort of shape, it's an exponential, okay? So if I was then to say, all right, what about if I had 4e to the minus kt? Now don't forget here, this is our t axis here and this is our w axis. So changing t's into negative t's, that just gives it a reflection about the vertical axis, doesn't it? So it's going to flop it around to be something like this. And then if I consider what's going to happen if I made a big negative sit out the front there. Now isn't a negative here the same as rearranging it so the negative is here? So comparing these two graphs, isn't this now going to be a vertical reflection and it's going to flop down and look something like this? Okay, and then the last step, lifting this thing up 8, at the moment it's got an asymptote here at 0, so my big graph, which is my final one, or my good version, has an asymptote up here at 8. I know that it starts out here at 4. I'm not going to bother graphing negative time because we're only considering what happens from the initial moment to the start of the experiment onwards, but I know it's got this basic shape here and we've lifted it up, so that tells me it's looking something like this. And that's really all the detail that your graph needs. It needs the right starting point, it needs the asymptote that we're heading towards, and then it needs the right basic shape. And I think your understanding of these transformations really helps you to graph that quite easily.